But first we got to start off with the tape measure. This is the tool that we're going to use the majority of the time when we're fabricating, we're cutting stock, that sort of thing. It's widely used in many industries, and we need to know how to read it right, otherwise mistakes can be made. And here's an example of one of those mistakes. In '99, an error measurement cost NASA $125 million just because somebody misinterpreted a measurement. So we need to make sure that we're measuring correctly and accurately. Let's take a look at the inside of a tape measure and how it's constructed. So there is a outer case, usually made of plastic, a rolling mechanism. The majority of tape measures have a locking device of some sort on them. And the tapes are usually made of either steel or fiberglass construction. And a very important part is the front part, which is that clip, tang, frog. There's a lot of different names for it, but it's very important that we take care of that. That's an important part of the tape measure. They're held onto the tape using rivets, and those rivets are intentionally loose, and it's very specific how loose they are. It allows the tang to move back and forward the thickness of the tang itself. That way, when we're making inside measurements or outside measurements, that tang actually moves the correct width so that our measurement's accurate. If it didn't move, our measurement would be off by the thickness of that tang. So because of that, it's very important to take care of that tang. If that tang gets bent in any way, or those rivets become loose or wallered out, then your tape is going to be less accurate than if it were nice and straight 90 degrees and at the correct tension. If you've ever wondered what the measurement is on a tape measure, if you have one, it's for a specific purpose. I personally don't use it like this, but it is an option for you to use. If you are measuring inside something like a box, you can take a measurement with the tape and then add that dimension. That dimension is the dimension of the case itself. So adding those two dimensions should give you your overall dimension. So in the United States, we use the imperial standard method of measurement. Across the world, the metric system is used widely. In fact, we're pretty much the only people that don't use the metric system anymore. So we use the feet and inches. So there's 12 inches per foot. So the first part of the tape measure is graduated just in inches. And then after we reach the 12-inch mark or the 1 foot mark, the tape measure is graduated in both feet and inches. So 16 inches, if you look at the bottom picture of this tape measure here, we could also call that 1 foot 4. So there's no right or wrong of how you call it. We just want to be consistent. So if you're going to be talking in feet and inches or just straight inches, it's recommended that you just use the same way of articulating that measurement over and over again. So don't say 16 inches one time and then 1 foot 4 another. It just gets a little confusing. And each inch is broken down into smaller graduations. So depending on the type of tape that you buy, some of these might be smaller graduations than others. The smaller the graduation, meaning the distance in between the lines, the more accurate the tape is going to be. So in this instance, and it's pretty typical with most tape measures, this is broken down into 16th graduations, meaning that each one of those lines, the distance in between them, is a 16th of an inch. And you might see with some tape measures that the first foot is graduated in 30 seconds of an inch, just to allow you to get a greater degree of accuracy. With that being said, the potential accuracy of these tape measures is the graduation distance. So we can never be more accurate in this case than a 16th of an inch. Now, when it comes to reading a tape measure, we want to make sure that the tape measure is as straight and as tight as possible. Obviously, if there's any coils or anything like that in the tape measure, it's going to lead to inaccuracies. Also, if we haven't pulled the tape measure straight across, there's something called a sine error, cosine error, where we actually get a wrong measurement if it's not a direct line between the points that I'm measuring. So in this instance, we're just going to look at the tape measure and figure out which line best lines up with our part. Now, we're always going to go back. We're never going to count what we haven't gotten yet. So in this instance, we've come to 10 inches. We haven't got to 10 inches and a 16th yet, so we're not going to count that extra 16th of an inch. So in this instance, we've gone past the 1 foot mark. So we have two different ways that we can articulate this measurement. We could either call it 13 inches and a half or 13 and a half inches, or we could call it 1 foot, 1 inch and a half. So 1 foot, 1.5. Both of those are proper ways of identifying this measurement. Now let's see how you do with some measurements of your own.